Hello everyone. So last day we had discussed about the feature scaling and normalization. Today let's discuss about standardization. So standardization is a very important topic and often asked in technical interviews and also in your day-to-day life in machine learning journey. You will very frequently you will use the standardization. So what is the standardization? So it's a way of transforming your data so that it will follow mean is equal to 0, standard deviation is equal to 1. More of a formal way of saying this, that okay, it's a method of transforming your data or scale your data so that it follows the properties of standard normal distribution. That means nothing but mean is equal to 0 and standard deviation is equal to 1. Now how to convert your data? So that's we do finding the z-score for each element of the data. So now what is z-score? So z-score is nothing but each element of your data, that is x I wrote, minus mean by standard deviation. So now let's implement this formula and finding the z-score first. I'll go to in IPython. So I have got, basically I have taken the x is equal to a list of numbers 2442. So mean, what is the mean of this? So mean is basically 12 because summation of each element mined by, basically you can say the number of element is equal to 3, correct? And I find the standard deviation here. So this is by using this stats module and I got around 1.154. Okay, so just run it again. Now let's find out the z-score. To find out the z-score, what we need? First, each element of your data. Second, mean, what we have 3, and standard deviation, what we have 1.14. So let's do it with for the first element. So this is the formula of z-score, right? That we have showed here. I mean, here I have showed you, right? This is the same formula. For the first element, z is equal to, what is the first element? 2. 2 minus 3 by sd, right? Sd is basically 1.154. So how much it is coming? It's equal to minus 860. Okay. So now for each element, if we do, I just wrote a for loop here. For loop I in x. So each element I am calling and I am putting each element into this formula. And then I am printing the actual original element I and z corresponding z score. Z score is equal to, you can see that, okay, 0.860 first minus 0.60 first element that we have already got. For second element it's this, third element is also this because both are same, and fourth element is equivalent to the first element is this. Now this is the numbers, these numbers are following basically the property of standard normal distribution. So that means we have standardized this, we have done the standardization for these elements. Okay. So now if we put these elements into a list, so suppose list distribution is equal to append, just put a z-score here. Now you do this mean of, so if we just stats or mean of list and we will write the stat of standard deviation, right? First run this standard deviation. Let's see what is the standard deviation. See now the standard deviation of this particular values are coming 1, and if you go the mean would be 0. So now, that means that the new numbers, I mean new data points, which is basically we put it into the list, are which is the Z score of this 2442 are following basically a distribution where basically mean is equal to 0 and standard deviation is equal to 1. So that means we have successfully done the standardization. Now let's see how standardization behaves with outlier. So we saw in the what it called, we saw in the normalizations that okay, if there is an outlier, it affects the each and every element of your data, right? So now let's see how it happened in the outlier. So now I put it 100. So 100 is basically an outlier here. So now you see that okay, standardization depends on basically two things. One is mean and then standard deviation. So now let's see. So let's take the mean here. I think the means are we need to. And the mean is now 28, right? Now let's do the standard deviation. Standard deviation is 43. Now implementing this value, the mean went 3 to 28 and standard deviation now here. Now if I find the Z score, what will be? So first earlier it was like 0.86, right? Minus 0.86, and now it is 0.02. And now if I just put here, now see here. So Z score, so okay, so this is basically mean was I haven't calculated, so that's why. So Z score for 2 now become 0.5. Earlier it was 0.8, right? Minus 0.8. Now 4 became this is became this 0.5, and this is also this, right? And the max value, which is basically 100, so that is came here. Now see, earlier it was, yes, standardization, so outlier in standardizations also affects, but if you see the numbers are near about the mean, so new mean we say that okay, this is 0, and so if you see the numbers which are not very far from the mean, so that means yeah, it affects but comparatively less from standardization, normalization. So if you just put it here, so you see like minus 0.12 is basically the new mean because of these things, and it is basically a near, very near to, you can say, with 0, and this is the standard deviation. So what we learned? Yeah, we learned from the last 2 days what is feature scaling, what is normalization, and what is standardization. We saw that okay, how to derive from Z score, and now we saw that okay, what is the effect of, you can say, the with one outliers, right? This one. When standardization is we use, so majorly when we see that okay, data is in a following the Gaussian distribution, or your algorithm or machine learning or deep learning algorithm assumes the data should follow the Gaussian distribution, like gradient descent, right? So gradient descent always do that. So that's why we always go with standardization. So now once we done with the standardization, the next step is basically using this, how to use it using scikit-learn. So that we will show, or we will do it in next class. Till now, we have covered these three major topics: feature scaling and its two technique, normalization and standardization. Please feel free to ask any questions in the comment, And if you like the video, please do like, share and subscribe. Thank you everyone, and we'll see you soon.